In this video, we're going to be changing the order of integration in cylindrical coordinates. So we have this example over here. I want to change the order of integration and evaluate the integral. And the order is given to be dr, dz, d theta. So the limits of r, see here, r is equal to 0, r is equal to 0 over 3. So if we try and sketch this, r is equal to 0 is just the origin, and r is equal to 0 over 3. Well, let me rearrange this. I'm gonna multiply both sides by 3, so we get 3r is equal to z. And z equal to 3r, that's an equation of a cone. So if you sketch this on the zr plane, that's a line, straight line with slope equal to 3. So this is gonna be 3r. And if you sketch this on the xyz plane, well, the radius can go in any direction. It goes radially outwards in all directions. And as we move radially outwards, the value of z increases, so this becomes an equation of a cone. And this over here, z is equal to 3r. Z is equal to 3r. And we're told that z ranges between 0 and 3. So z equal to 0 is just the xy plane. Z equal to 3, that's the infinite plane at height z equal to 3. So it's this infinite plane. So the intersection between the plane and the cone is going to be a circle. And our solid becomes this over here. So that's solid. And theta ranges between 0 and 2 pi means we have a complete circle, or it's defined in the 4 quadrants on the xy plane. Okay, so now that we have an idea what the solid looks like, we can change the order of integration. So we can do it r cubed, we can go dz, dr, d theta. Okay, so let's set the limits in the z direction. In order to do this, we're going to draw arrows in the positive z direction. And you see that we always enter the region through this line over here, through the cone. And we know that the cone is defined by z is equal to 3r. So the lower limit is going to be z equal to 3r. And the upper limit, we see that we always exit the region through this plane, which is z equal to 3. Now we can find the limits in terms of r and theta. So you look at the projection of the shape on the xy plane. The projection of the shape is going to be a circle that's centered at the origin, so the lower value is going to be 0, and the upper limit is going to be the radius of this circle. Now, one way we can find the radius of this circle is to find the intersection between the cone and the plane, because this circle over here is the projection of this circle, the red one here, and the red circle is the intersection between the plane z equal to 3 and z equal to 3r. If we equate both equations, we have 3 is equal to 3r, the 3's cancel, which means that r is equal to 1. So this circle over here has a radius equal to 1, which means that this radius has a radius that's equal to 1. So the upper limit of the radius is equal to 1. And finally theta, the projection of the solid on the xy plane is a complete circle centered at the origin, so theta is going to be range from 0 to 2 pi. Okay, now we change the order of integration, and we can integrate. So let's evaluate this. If we integrate r cubed with respect to z, we're going to have r cubed z evaluated at z is equal to 3r and z equal to 3. So this is going to be 3r cubed minus 3r to the power 4 dr d theta. We said that r ranges between 0 and 1, theta ranges between 0 and 2 pi. Now we integrate this with respect to r, so we get 3 r to the power 4 divided by 4 minus 3r to the power of 5 divided by 5. It's going to be evaluated from 0 to 1, which is going to give us 3 over 4 minus 3 over 5. It's going to be 20. It's 15 minus 12. It's equal to 3 over 20. So now we're integrating from 0 to 2 pi, 3 over 20 d theta. So that's going to be 3 over 20 times 2 pi. The 2 cancel with the 20, we get 10, so that's going to be 3 pi over 10. And that's the final answer.